Assalamualaikum warahmatullahi taala wabarakatuh. Okay, we from uh, BEI session 1 talk 2. Okay, my name is Muhammad Ashraful AIMAN bin ABDUL. My teammate is NURUL binti RAMLI and NURUL binti Zuraini. Okay, today we would like to present our lab 4, which is the title is DC high voltage measurement and monitoring. Okay, so for the section 1, okay, for section 1, I will be back on this. Okay, so as you can see, figure 1 and figure 2 shows the electrical schematic circuit and schematic circuit of measuring section, which is the connection taken from the termination of 100 picofarad capacitor female, which is connected by the short coaxial cable 40 cm to adapter A and connected to secondary capacitive device, while adapter B connected to another side of secondary capacitive device, and female side of adapter B connected to the male of the T junction. The T junction connector have two sides, which is the right side connected to the frequency converter by using the long coaxial cable, while the left side is connected to frequency probe and by using a long coaxial cable. Okay, as you can see from the figure 1, from the capacitive measuring device, it is connected to the rectifier 20 mA, which is the function is talking voltage. Is per unit 140 kV. So we can conclude that the blocking voltage is approximately approach 280 kV. Is that it is two rectifier connected. Then it is connected to the smoothing capacitor in value of 25 nanofarad, which is the purpose is to reduce ripple and can be used as energy storage capacitor for generation of pulse voltage or as smoothing capacitor for DC generation. Then it connected with the resistor 2.4 kilo ohm, which is used for discharging purpose, which is to reduce damping circuit and to reduce impact charging capacitor while transferring charge. And then it's connected to the resistive measuring capacitor, and it connected with the secondary resistive device as a connection to the which is connected to the microscope and the frequency converter. Okay. For the grounding, ferrite copper is attached with the 100 picofarad capacitor, then connected to the secondary capacitive device, and then it connected to the resistive measuring resistor 280 mega ohm, and the second resistive secondary resistive device, and it connected to the frequency converter. For the safety rules section, we need to make sure that the coaxial cable is connected fully at the T junction at the bottom of the floor pedestal. Secondly, we need to check that the loading switch is always touching the top electrode, and also we must ensure that the testing layout is clean and cable are neatly arranged. Okay, for section 2, I will pass to NURUL SYAZWANI.
Okay, my name is SYAZWANI and I will explain about the section 2. Section 2 is the configuration of procedure of setting the kit control and picoscope. For the source control, is the value set for the input high voltage. It is to increase and decrease the voltage value. For this DC configuration, the source control is increased in each step from 0% to 50%. For the primary side of the transformer progress, the primary side of the transformer is shown in the figure below. It is used to display the inject voltage and current. By increasing the percentage at the source control, the result will be shown at the scope as per step. The third one is the system monitoring of secondary side of the transformer with 8 slot. The 8 slot is appearing as a numbering result. Channel B is used for DC voltage. It is connected to VM3 at the frequency converter. Each of the channel has 2 slots of the system monitor. By referring to the figure below, the result for the DC can be seen at the 5th slot. Okay, for the alarm system is to indicate if there is a problem with the system. The moment when the red color is indicated, it will not be able to do any injection. Okay, the serial number and voltage divider multiplier is 22341182-03 and voltage divider ratio is 20414.4. Okay, this is the customer setup setting. There are two setup in the kit control that are FC setup and customer setup. FC setup is done by the manufacturing company. For the configuration for customer setup, manual step has constable, corporal and sergeant. As for the constable, the gain is 0.1. Corporal has gain of 1 and the fastest step is sergeant, the gain is 10. The setup for the impulse sequence setting and component setup is not our consideration. The important part is calibration. Channel 1 is for AC, channel 3 is for DC. In slot 5, insert the divider ratio that is stated above and click the save button. Okay, this is the function of picoscope. The first one is acquisition setting. For acquisition sample, the value is set from 0 to 100K. It is stand for number of sampling. For sampling interval, it is the accuracy of the measurement. It is the resolution between 2 points. It is set to 10 micro. This is the trigger active. This is used for triggering such as impulse. It is purposely used to capture the signal. Need to active the trigger active button and set the impulse. The value of the trigger threshold also need to be set. Okay, this is the channel. It has 4 channels, that is channel A, channel B, C and D. Because at real picoscope equipment also have 4 channels. Need to active the channel B because we use channel B for this lab experiment. Make sure the channel must be activated by click on the button. The coupling is set to DC coupling and the divider ratio is set the same as in the manual book. Okay, and for the DC tab, the section will show the value in min value, max value, minimum value, ripple factor and ripple PP. And for the section 3, I will pass to Nurul to present. Thank you.
Okay, my name is NURUL. I will explain for the section 3, which is comparison for analyzing the reference signal from kit control and display signal from picoscope. This is the value at the reference voltage and display, and this is the error. For this DC high voltage measurement and monitoring, the frequency used is 50 Hz, same as the AC configuration. Based on the percentage of error calculation between the result of reference, kit control and display, which is picoscope, it shows that when the output voltage is increased, the percentage error is decreased. This is due to the resistance effect, since for DC configuration we use resistive type. It is also due to the effect from picoscope and kit control in terms of sensitivity range of scope and the coupling setting. Accurate measurement assured by calibration can improve safety by helping to maintain the proper environment for certain processes, especially those that are hypersensitive. In conclusion, student is able to construct parallel DC high voltage measurement using kit control 4.0 and picoscope 3000 series. The procedure for setting the kit control 4.0 and picoscope 3000 series can be familiarized. The value obtained from kit control reference and picoscope 3000 series, which is displayed, can be compared and analyzed by calculate the percentage error. There is a difference by testing using AC and DC, since it use capacity for AC and resistive for DC. That's all from us. Thank you.